Another application of binary matrices is communication matrices. So in this case, we use square matrices consisting, again, entirely of ones and zeros to represent links between two people. So if a person can directly communicate with another person, we would put a 1 in the matrix to represent that. If a person cannot communicate directly with another person, we would use a 0 in the matrix to represent that. So in the first matrix, the communication matrix C, it's normally called, we represent the direct communications between people. If we squared that C matrix, C squared, we end up representing the two-step communications between those same people. So a two-step communication link would indicate that I can't directly speak to someone, but I could speak to somebody else that could then speak to that person. So it's going through someone else to speak to someone. So that it sort of involves two steps to get the communication to that second person. When we're doing communication matrices, again, if I wanted a 3-step communication link, I would do C cubed to the power of 3. So we generally, in these kind of questions, calculate a total communication matrix, which involves us adding the 1-step and the 2-step communication links together. So we'll work through one that was in your notes booklet. And in this example, we're given the names of 4 people, and we're asked to look at the little network diagram there, the links between certain people. These people speak different languages and obviously are not able to communicate directly with each other, but some people can speak similar languages, obviously. So there is links between some people and not between others, as you can see with the arrows there. So the arrows going both directions in this example mean, for example, Yumi is able to speak with Wong, and Wong is also able to speak with Yumi directly. The arrows are going two ways in all of those links. So we can see that the question is asking us to construct the 1-step communication matrix. So this matrix that we're constructing is to represent who can directly communicate with who. So because the question gave the order, Eva, Wong, Yumi, Kim, I've just stuck with that order E, W, Y, K on my matrix. So it doesn't really make much difference, but I think it makes sense to use the same order as what's written in the question. So if we look at our little network connection diagram there, we basically are looking from the left to the top of that matrix and saying, can Eva communicate with Eva? Basically, no. So we'd put a 0. The leading diagonal here will all be zeros because it makes 0 sense for someone to communicate with themselves. So we call that diagonal in a communication matrix a redundant link. Okay, so when we do the 2-step link, often there is numbers that are not zeros in that diagonal. They are links, but they're called redundant links because they're sort of meaningless. It is possible to speak to someone else who can then speak back to you, for example, but it's not a valid link. So we call those redundant links. So looking at our a little network there, if we're looking across the row Eva, we check who she can communicate with. Eva can only communicate directly with Wong, okay, and then not the others. When you're looking at Wong in the middle, Wong can communicate with everybody else. So we can put 1s in all 3 of the other little spots. When we look at Yumi, Yumi can only communicate with Wong, so we'd put a 1 where Yumi and Wong intersect and a 0 everywhere else. And then we're looking at Kim, she can only communicate with Wong. Okay, can't communicate with Eva, can't communicate directly with Yumi either, so 0 in there. So there's our C matrix, our one step or our direct communication link matrix. So we've got that now sorted. Sometimes you're asked to look at the matrix and interpret what a particular element might mean. This one here is asking us for element C2, 3. So in row 2 and column 3, this element here is a 1, and what that represents in words, it wants you to say that. So you can look there, that's the intersection on that matrix where Wong and Yumi intersect. So basically what that is saying, that element being a 1, means that Wong can directly communicate with Yumi. Okay, so Wong directly communicate with Yumi. Okay, if we're calculating the two-step communication matrix, we would take that C matrix that we just made and square it. Okay, so on the calculator you'd need to type in that C matrix, raise it to the power of, I'm just going to put it in there properly, and then I'm going to raise it to the power of 2. So this matrix is our C squared matrix. So you can see what I was talking about before with the leading diagonal there. There's a 1 in all of the spots there, except there's a 3 in the second spot. So they're all links, meaning that there is two-step communications from one person to themselves. They're legitimate links, but we don't need to worry about those. They're redundant. It means nothing to communicate with yourself. So if we write that matrix as our C squared matrix, that's what that question's asking for. So sometimes you're just asked to just state it, write it down, calculate it, whatever, and sometimes then you're asked to do more with it. So the next part of this question asks us to calculate the total communication matrix. And what that means in English is that they want us to take matrix C, the one-step communications, and add it to the two-step communication links. So we're basically putting in our calculator the C matrix plus the C squared matrix to end up with a total communication matrix. Okay, so on your calculator, if you were doing that, you would take your C matrix and you would add it to your C squared matrix to get what we call the total communication matrix. So if the question asks you to write the total communication matrix, you'd have to write that down, and I think this question does do that. So calculate the total communication matrix, we would need to write that down. So 1, 1, 1, 1. So that C plus C squared gives me total communication matrix. So in terms of an exam question or a SAC question, if we're asking for total communication, we want one-step and two-step communication links added together. So what we then sort of look at, where it asks in the question next, who has the most communication links, it means reading across the rows for each specific person what their total communication links are. So we write a little vector that tells us the totals of those rows, and you'd see you'd have 4, 6, 4, 4, and those 4 totals are still in this order, E, W, Y, K. Okay, so Eva, Wong, Yumi, Kim. So they relate to the same order as our starting point. And it says who has the most communication links. You can see there that Wong has the most communication links, so the answer to that question is Wong. and you've got listed there the calculations for that. It's telling us in part E, Yumi has a value of 4, which we can also see from here. Explain what this is referring to and the communication that occurs with others. So you basically, what it's saying there is Yumi has a total of 4 one-step and two-step communications with other people.